In this example, we're asked to graph the function on the calculator, sketch it, and then analyze the function. Okay, so our first job is to graph the function. So hit y equals and type in x cubed plus 2x squared minus 3x. A lot of people forget to do this first very basic step, but it's always the first thing you absolutely have to do. We are going to be asked, if you read the question, we are going to be asked for zeros a little bit later on. We've done finding zeros before, and the easiest way that we found to do it was to put in 0 as y2, y2 equals 0. Okay, so graph that, and the way we graph it is zoom 6. And we're going to sketch that graph here. Okay, we're going to sketch that graph here, and it kind of goes through the origin. It seems to go through the origin at least. And it does something like this. Okay, it doesn't have to be very accurate, but that seems to be pretty good. Now, we've got to analyze the function for its zeros. Now, if you check that, that's why we put in y2 equals 0. So let's write that down. So we said y1 is equal to x cubed plus 2x squared minus 3x, and y2 is equal to 0. The reason we did that was to calculate, or to find the zeros in the calculator. Okay, so finding zeros. And again, this is something we've done already this year, but it's easy to forget. So what we're going to do is we're going to press second and calc, and one of the options that we're going to have when we do that is number 2 is 0, but we're not going to use that because we've done this before, and we did it using the intersect menu instead. So we're going to pick 5 intersect, and the reason we can do that is because we set y2 equal to 0. That's the only reason we did it, and that allows us to do it this way. Now if you look at your sketch first, there are 3 places where this graph crosses the x-axis. Those are the zeros. Okay, so the zeros are the points where the graph crosses the x-axis. Okay. And now what we're going to do, we're going to hit 5 for intersect, and let's move first one to the green. Okay, so what we'll do is we'll move our flashing cursor over to over close to where I have drawn the green dot here, and press enter 3 times, once, twice, 3 times, and you're told that x is equal to -3. Okay, so that for that first one, x is equal to -3. The second one was in red. Okay, so we do second calc 5 intersect again. Every time we do a new one, we do second calc 5. And we move over to where I have drawn the red dot, which is at the origin, or very close to it. Get as close as you can to that. And press enter. Once, twice, 3 times. And it tells us intersection is at x equals 0. And then there's one more, there's the orange one. So repeat the whole process, second calc 5, and move over to where I've drawn the orange one, and press enter 3 times, once, twice, 3 times, and you get x equals 1. Okay, those are where this graph has zeros. Now we're asked to find the relative extrema. Okay. Okay, so the relative extrema. The relative extrema, what that means are the maxima and minima. In other words, where does this graph have reached its highest and lowest points compared to those around them? What are the tops of the hills, the bottoms of the valleys? Again, if we look at the graph, there's a relative max, and there's a relative min. Now the difference here is that for maxima and minima, In the extrema, we're looking for the y coordinates. Okay, so the extrema, what we want for the extrema are going to be the y coordinates. Okay, now anytime you're trying to do anything with a graph, it's second calc. So let's say if we look back at the sketch here, the top of this little hill. Okay, so that's the relative maximum we're going for first of all. So if we go for the maximum, the way to do that is to go second calc again. Anytime we're working with a graph, we're going to go second calc, and then for a maximum, we're going to push 4 for maximum. So let's do that. So second calc and hit 4 for maximum, and we want to move over to the maximum. So we want to move over here. And if you look at the calculator, your graph is your cursor is flashing there. So let's move it over close to that peak. And then the calculator tells us what to do. So we go where we want to first, and then the calculator tells us what to do. It says go to the left. Okay, let's go to the left a few clicks and hit enter. And then it says right. The calculator says right, so go to the right of the point and hit enter one more time. And we get x is equal to 1.868, but y is equal to 6.064. So y is equal to 6.06, let's say. Round it off there. Now the relative minimum, okay, the relative minimum, that's down near the bottom. Okay, that's going to be second calc and then 3 minimum. So let's repeat that. So second calc and then 3 minimum. So 4 for max, 3 for minimum, but it tells you that anyway. Move to where the minimum is. Okay, move to where the minimum is. And if we look at the sketch, we had the relative minimum down here. Okay, so move your cursor keys to work on the calculator now. Work down to the bottom. Press enter. Oh, sorry. I might need to do this again. So just cancel that. So second calc. Hit enter too quickly. So now I'm down here at the bottom. Second, let's do this again. Second calc, and then I want 3. Second calc 3. Okay, so I'm down at the bottom. I'm down where I want to be. I'm down at the bottom, but I have to move to the left a little bit. So move to the left a few clicks, press enter, and it says move to the right. So go down through the point and move to the right, press enter, and for the guess, just press enter again. And it's going to tell you the minimum is when y is equal to negative 0.879. So y is equal to negative 0.879 or is negative 0.88. Okay, so the extrema, the maximums, you give the y coordinates. For the zeros, you give the x coordinates. Okay, now use your calculator to find f of negative 1.25. F of negative 1.25. Okay, so this is the last thing. F of negative 1.25. So if you want to find the graph's value or the function's value at a particular value of x, this is what you do. You do second calc, and you pick one value, and the calculator is going to ask you, we're going to check this in a minute, it's going to say x equals what, and then that's where you type in 1.25, negative 1.25. Okay. So we're going to type that in, and then, oops, let's see if we can get this back to where we want it. Okay, it's a little bit better. So go second calc, and number 1 value, and x equals, and you type in negative 1.25. Oh my goodness. Okay, press enter. And the value is the y coordinate. You can see the cursor flashing. The value is the y coordinate. Y equals 4.92. Okay. Y equals 4.92. I'm not quite sure what's going on with me today. 4.92. So that means f of negative 1.25 is equal to 4.92. Right. The final thing we were asked is not something that we need to use the calculator for. State both the domain and the range of the function. Well, the domain is what kind of x values can be put in here, and since it's a polynomial, the domain is all real numbers. And since it's and the range is all the different types of y values that you can get as an answer. And you can see that this graph, if we look at the graph, it goes down forever and ever in that direction, and ever in that direction. So it goes down as far as you want, and up as far as you want. So both the domain and the range are from infinity to infinity, are all real numbers. Okay, so that's the last question that we're going to answer. Domain is all real numbers. Write these in lots of different ways, but let's say from negative infinity to infinity. And the range is going to be exactly the same thing. So the domain are the x values, the range are the y values. And that's got them there. So that's 11 minutes. Apologize for taking up so much of your time, but thanks for watching. Hope you learned something.